Hello everyone, my name is Mehrunisha and I am from group 324 and today's my topic is properties of materials. So if we take in this we can discuss stress strain relationship, the constitutive equation. If we take a rod of some material and subject it to a load along its axis, we expect that it will change its length. We might draw a load displacement curve based on experimental data. So the curve is displacement and load, and it is like this. So we could construct a curve like this and for any road, but it is obvious that its shape depends on the geometry of the road as much as on the properties of any material from which it is made. We could, however, chop the rod up into smaller elements, and apart from difficulties close to the ends, we might reasonably assume that each element of the same dimension carries the same amount of load and extends by the same amount. We might then describe the displacement in terms of expression per unit length, which we call strain, and the load in terms of load per unit area, which we call a stress. We can then draw the load displacement curve as a strain or stress curve, and this could be independent of the dimensions of the bar. The shape of the stress strain is typical of many engineering materials and particularly of metals and alloys. There is a linear portion between the origin O and the point Y. The linearity of the equivalent portion of the load displacement curve is known as Hooke's law. Hooke's law. For many materials, a bar loaded to any point on the portion OY of the stress strain curve and the unloaded will return to its original stress and stress length. It follows the same line during unloading as it did during loading. This property of material is known as elasticity. That is elasticity. In this context, it is not necessary for the curve to be linear. The important characteristic is the similarity of loading and unloading process. A material that exhibits this property and has a straight portion OY is referred to as a linear elastic in this region. The linear relationship between stress and strain holds up only to point Y. After this point, the relationship is non-linear and the open slope of the curve drops off very quickly after this point. Thank you.